All right, everybody, welcome to our next session here at Miss Shazara. We're going to we're going to um we're going to knock off our next little topic in chemistry here. Just a recap. There's not a full class or anything. Just a recap of electrolysis. I'm glad that I have Miss Shazara here. Those of you all who are watching this, you could also look for my playlist. If you need a review on organic, you could just search Cool Spring Organic Chemistry. I was watching it today. It's good quality stuff that could still apply. We also did a video earlier this week on moles, so y'all could look up that. And just search Cuban Springer Chemistry for the different things that we did on chemistry, all right? So, exam right around the corner, so we're not going to wait too long. Excuse me, there are 67 of you all here. Press like on the video. I'm not seeing the comments. Can you all just say something or type something there? Hey, yo, Summer. Right, I'm seeing Summer Lee here. Summer Lee, like salty and everything. How the exam season going so far? All right, just seeing my comments here. People ready and waiting. Abriana, Shamaya. Right, nice. Any physics here to hear us? Well, I was planning to come on physics and do some physics Sunday night, like around 9 o'clock. But I just realized that my crash course, the 12-hour crash course, starting 11 a.m. tomorrow and finishing 11 p.m. So I might actually come on a little earlier to try and sneak in a half an hour earlier and bring it to like 10:30 so we didn't go too late. In the future, all our 12-hour crash courses is going to cut off at like around 9. Last year, all the crash courses was finishing 11 or so, but we end up kind of bring it up a little early so people get a little more chance to recap stuff that we do in the crash course if it's the day before. But physics is not the day before the exam. Anyhow, I don't want to talk too much, so if you all want to join Miss Christie's class, you want to join any class in the Student Hub #1 online platform for lessons in the Caribbean. The number to WhatsApp is just now earlier. Have it here. Have it loaded. Bang. Oh, this is what for Miss Akili. But for any class, you can WhatsApp this number here and below. +1 868 472 4221. And you're gonna be in the game, right? So Shazara, thanks for coming in again.
You're welcome. Good night again, everyone. So tonight we're going to focus on a little bit of electrolysis. So can you all tell me, how do you all feel about the topic? And I saw one question about the physics crash course, if it would cater to somebody weak in the subject. So yes, the crash course is an entire syllabus review, so it will be really helpful. And this is for CSEC chemistry. So I'm seeing good, hate it, all right. Now, if you guys took a look at some of the past paper questions in the most recent years, you would notice that electrolysis comes in almost most papers. So it came for Jan 2024, May, June 2023. It was in both Jan and May, June of 2022. So in some way or form, electrolysis was tested. And if they continue with that pattern, it is a very good subject to make sure you guys pay attention to. So I'm seeing another question, is the crash course for chem or phys? The crash course tomorrow is for phys. The chem crash course, the live session has already gone, but you guys could still get access to everything. You could just message the number Mr. Springer had on the screen before. All right, so I'm seeing generally you guys understand a little bit of the topic. And with electrolysis, we have a simpler case and we have a more complicated case. Electrolysis of molten solutions is really simple, but when we have questions with aqueous solutions, it tends to get a bit more difficult. Nicholas has electrolysis is a decomposition of an electrolyte by the passage of an electric current. So great job. So what we want to focus on tonight is some of the latest questions that came on electrolysis. So let's start off with this Jan 2024 question. And it says figure 5 would represent some circuit diagrams which shows the apparatus that was used to conduct an investigation to determine which materials are conductors or non-conductors of electricity. So just going back to Nicholas's definition, an electrolyte is a conductor. In order for a current to pass through, your electrolyte must conduct the current. So it could be an aqueous solution, meaning something that's dissolved in water. It could be a molten solution, which just means melted. So the following materials were tested: copper coins, plastic, glass, aluminum can. Complete the table below by classifying the materials as conductors or non-conductors. So guys, can you all tell me which ones of these would fall under conductors? So Robin, this class is scheduled to finish around 7. It's only a 1-hour session. So Isaiah, conductors would be the copper coin. All right, excellent. Because copper is a metal and metal can conduct current. The aluminum can as well. The reasoning is the same because aluminum is a metal. Now for our non-conductors. A non-conductor and insulator means that it cannot conduct a current. And do you guys know what is necessary in order for a current to be conducted? There are 2 conditions that should be satisfied. So Luke says because it is a metal, right? And metals contain a sea of mobile electrons. So it's a free particle with a charge and it can move. Plastic is a non-conductor, excellent, because with plastic we do not have any particle with a charge that's able to move. And what about glass? Glass is also a non-conductor. So just remember, in order to classify something as a conductor, it must have a charged particle. That could be delocalized electrons, meaning free electrons, or what is the other charged particle that we have in chemistry? Think of ionic compounds. When we dissolve an ionic compound, what is free to move? And a hint, it starts with I. Ions, excellent. So you must have ions or electrons and they must be free to move. That is the only 2 conditions you must satisfy. So this was an easy 2 marks. Now what has been really common in electrolysis questions is for you guys to be able to identify your anode and your cathode. In order to conduct an electrolysis process, you need an electrolytic cell. There are 3 components: a battery, you need your electrodes, and the solution that you are seeing is your electrolyte. So state one way in which the conduction of electricity in the solution of sodium chloride is different from that in copper coins. They both are electrolytes. They both will conduct a current, but it's different. Let's start off with the copper coin. How will current be conducted? And a hint, we are looking at copper. Copper is a metal, right? And do you all know the type of bonding that takes place within a metal? Summer says metallic bonding. Excellent job. So copper will produce a pink film around the cathode. Correct. We'll come back to that in a bit. So inside of our metal, we have our atoms that are tightly packed together. And I'm just going to make a sketch of this. The electrons in the outermost shell become delocalized. So it becomes detached and it's free to move about throughout your structure. So for the copper coin, a current will be conducted due to the delocalized electrons, which are free to move and conduct a current. So what about in sodium chloride now? NaCl. Can you guys identify what type of bonding takes place here? Sodium is a metal, chlorine is a non-metal, so it's ionic. Excellent. So delocalized electrons are what conducts current in metal, correct? And for ionic compounds, what particle do we have that could move and conduct the current? When sodium chloride dissolves in water, we would have Na plus ions, Cl minus ions. Dissolving it in water, you are essentially breaking the ionic bond between them. So your ions are free to move and conduct a current. So make sure you guys can understand the difference between this. In metallic bonding, it's the delocalized or the free electrons that are able to move and conduct a current. In any ionic compound, whether it's melted or dissolved in water, it will be able to conduct, and it is because of the ions that could move. State which electrode is the cathode and which one is the anode. So let's go back to that figure. And can you guys figure out which side is the positive side and which side is the negative side of your battery? You were lucky in this question, they indicated it, but usually they don't tell you which side is positive and which is negative. So the bigger line represents the positive terminal. The smaller one is your negative terminal. So that means A is going to be your positive electrode. So I'm seeing A is anode, right? Your anode attracts anions. Anions are negative in charge. And in order for us to attract something negative, the electrode itself has to be opposite. It has to have a positive charge. The other side now, where we have the negative electrode, this is going to attract positively charged ions, cations. So the cathode attracts cations. So do you all agree that A is the anode and B is the cathode? So our cathode is going to be B and the anode is going to be A. Do not mix it up. I know when you think the word anode, it's similar to anions. You might want to associate it with a negative charge. But remember, your anode has to attract the anions. In order to do so, it has to be opposite. So are we going to do any other topics later? So this is just a session focusing on electrolysis. So we only have a short period of time. So that's why we're just focusing on this one topic today. Part 3 is to write balanced half equations to show the substances produced at the cathode and at the anode. This is electrolysis of a dilute aqueous solution of sodium chloride. Do you all know how many factors we need to consider in order to figure out what is going to be discharged at your cathode? All right, so I'm seeing at the cathode, your answer is correct, but at the anode, we need to come back to that first part. So Alyssa, 3 is for your anode, but for your cathode, it's just one factor. Does anyone know what that one factor might be? The electromagnetic series, well, we call it the electrochemical series, right? So what we are going to do, we are going to write down all of the ions that's present in this solution. We are currently dealing with sodium chloride and water. So could you guys tell me what are the 4 ions in this solution? If it helps, let's start with water. What are the ions inside of water? So Maria, for organic, Mr. Springer has a playlist on organic. You could refer to that, all right? So Na plus, Cl minus, H plus, and OH minus. So excellent. So let's focus on the cations first. There's only one factor to consider, and that is the position in the electrochemical series. How many of you have learned of your electrochemical series? You could just type Y for yes and for no. And this here is your electrochemical series, very similar to your reactivity series. All right, so Nicholas, excellent job. For those of you that have not, you absolutely need to. You can't solve these questions without it. So let's locate where sodium is and where hydrogen is in the electrochemical series. Which one do you think is going to be discharged? Now there's a competition here. We have 2 ions that's going to be attracted to the cathode, but the cathode could only discharge 1. So we call this a competition to see which ion is going to be discharged in preference. The higher up the ion is, it means the more stable it is. That will also mean you need more energy to discharge it. So electrolysis, we want to use the least amount of energy possible. So we will go with the ion that is lower. So someone says whichever one is lower in the series, and that is correct. So do you all agree that H plus is lower in the series? So it will be discharged in preference? It's not going to be sodium. Please don't make this mistake. Sodium would never be discharged unless it's a molten solution. In a molten solution, you only have the ions in your compound itself. You do not have water. So only in that case, then would sodium come out. Otherwise, it's too reactive. It requires way too much energy. All right. Do you all know how to come up with your half equations? There's only one I will tell you guys to learn off for your exam. But for the rest of them, we can come up with it. So going back, at our cathode, we have H plus being discharged. And it's an aqueous solution, so I'm putting the aqueous state symbol. The first thing I will tell you guys to do is to figure out how many electrons we have to add or take away to get back 1 atom. So to figure out what is coming here, you don't actually have to remember anything. Just take a look at the charge on your ion. The same charge and the same number, you are writing it back in front of the electrons. So what is the charge you guys are seeing? So it wouldn't be +2 here initially. When we balance it, we'll get +2. So I'm putting back the same positive sign. And on hydrogen, it's a +1. So I'm putting back that 1 there initially. But we now need to ask ourselves, is hydrogen a metal or a non-metal? If it is a metal, it could exist as an atom. If it's a non-metal, it will form a molecule. So that's why it's important to be familiar with the characteristics of the elements. It's non-metal. Okay. So will we leave hydrogen as an atom or will we form H2? Zia says H2. Correct. And what is the state symbol for hydrogen? Is it going to be solid, liquid, gas, or aqueous? And we call this a diatomic molecule. Two atoms have covalently bonded together to give us what we call a molecule. And this is in a gaseous state. Excellent. Now we need to balance this. And whenever you are balancing a half equation, I would tell you guys not to look at the number of electrons as yet. Look at the number of atoms and the number of ions. We have 2 hydrogen atoms being produced, but only 1 ion. So what number will we multiply by here in order to get 2? So hydrogen wouldn't be a solid, hydrogen would be a gas. Your nonmetals tend to exist as a gaseous compound. Correct, we'll be putting 2. Now if I put 2 in front of there, now I need to alter the number in front of my electrons. So I will have to multiply this number by 2. So I'm changing this to 2. And this is actually our balanced half equation for what is taking place at the cathode. So any questions before we move on to figuring out what is going to be discharged on the anode? There's only one equation that you guys have to learn off. Otherwise, you can come up with all of your half equations for electrolysis using the same method. So whatever you do on one side, you have to do on the other. So yes, only if you have to adjust the number in front of the ion, then you need to adjust the number in front of your electrons. But you are not using the number of electrons to help you balance initially. How did we get H2O? So H2, because hydrogen is a non-metal, it will not exist as an atom. It will immediately bond with another hydrogen atom. So which equation do you have to learn off? I will show you guys that with the anode. So let's go over one more time. Isaiah, if the number of electrons are negative, correct. We would carry it across on the other side just because they always want to see a positive sign in front of the electrons. So let's start again. We all agree that hydrogen is lower in the electrochemical series, so it's going to be discharged in preference. We want to get a balanced half equation. So the first step we are going to do is figure out how many electrons we need to either add or take away to get one atom. This is just the starting point. To figure out this, we just look at the charge on the ion. So hydrogen has a 1 plus charge, so I'm just writing back plus 1. So is everyone okay up till here? All I did was write back the charge on the ion as a coefficient in front of the electrons. And Maria wants to know, how did we get the 2 again? Okay. So at this point, we are looking at hydrogen. It's a non-metal. It will not exist as an atom. Only metals are stable enough to exist by themselves. All of your nonmetals will automatically bond to give you a molecule. So we are going to put 2 here. This is what we call a molecule. We have 2 atoms chemically bonded together, and our state symbol is going to be gas. You would notice that anytime you're dealing with nonmetals, for example, chlorine, it's Cl2, bromine, Br2, iodine, I2, oxygen, O2, etc. Because they are all nonmetals, they can't exist by themselves. How do you remember the charges? Well, that is where a little practice comes in. You could get a piece of paper and write the charges over and over until you remember them. Why would an electron be added though? It implies it is a cation. So remember, in order for hydrogen to have that +1 charge, it means it lost an electron in the first place. So we need to add back 1 electron to get back the neutral atom. Correct. And also for the anode, we need to figure out which ion is going to be discharged preferentially as well. Now, so far, we have only completed part of it. We need to make sure it's balanced. When we are balancing, do not look at the number of electrons initially. Just look at the number of atoms. So we have 2 atoms being produced and 1 ion. To balance it, you have to make sure you have the same number on both sides. So we are going to multiply the ions by 2. And because we now have 2 hydrogen ions, we need to change this number. This number has to be updated 2 by 1, which gives us 2. We have a positive sign in front of our electrons already. So this is our completed half equation at the cathode. At the anode now, how many factors do we need to consider? At the cathode, it was just 1 factor, the position in the electrochemical series, whichever one was lower, was our answer. At the anode, this one is a bit more complex because we have multiple factors to consider. And earlier, some of you gave me the answer 3. Correct. So can anyone tell me what those 3 factors are? And correct, in nonmetals, the type of bonding is covalent bonding. Excellent. So 2 or more nonmetals gives you a covalent compound. When we have a metal and a nonmetal, that would be ionic. The type of electrode, that is correct, the concentration, and the last one is the same exact one for the cathode. So I have the factors stated above in order of importance. So meaning, if the question stated that we are dealing with an active anode, then that is the factor you focus on. But notice in this question, it didn't mention anything about an active electrode, so I cross it out. This is not the factor we are using. Next is the concentration. The question stated the word dilute, so automatically we cross out the second factor. If it was concentrated, then it means if you have chlorine, bromine, or iodine present, that will be discharged. And lastly, it is the position in the electrochemical series. And this here is the electrochemical series for non-metals. Our anions would be the chloride anion. So I'm circling it here, Cl minus, and the OH minus. Which one do you think is going to be discharged in preference? And just like before, think of electrolysis as a lazy process. It wants to use the least amount of energy possible. So it will go with the ion that's less reactive. Dilute, correct, meaning that we have water added. So that's where the OH minus ion came from, the water. So it wouldn't be Cl minus. Cl minus is higher up, meaning it's more reactive. It would require more energy. the OH minus is lower down. So that is going to be discharged in preference. So anytime you guys are using the electrochemical series, whichever one is lower down, that is the ion that's going to be discharged. Only if you have a concentrated solution, then would a halogen ion come out. And OH would be the equation that I would tell you guys to learn off. So I'm going to write it on the screen. It's 4OH minus, and it will have an aqueous state symbol because remember it's dissolved. It's in a solution. Aqueous just means dissolved in a solvent. So 4OH minus to give 2 water. We have oxygen, and you are just missing the number of electrons, but good attempt. We have 2 water molecules. Water is a liquid, so it will have the liquid state symbol. Oxygen, notice how it's O2 and not just simply O. Oxygen is a nonmetal, so it will exist as a molecule. And lastly, we have 4 electrons. So I'm putting a star here. This is the one that you guys are going to learn off. The others, we can come up with it just like that first equation. All right. So any questions before we move on to the calculation part of it? This is the important part for you guys to remember. Make sure you know that for your cathode, it's one factor, just the position, but with the anode, it's 3 factors. So where did the 4 came from? It was just when we are balancing it. And doing the same procedure where we explain in detail where everything came from might confuse you guys. So that's why I'm saying that would be the only one to learn off. So if the OH minus ion will be discharged, yes, it's the same exact equation over and over. And you would notice that if H plus is discharged in the next question, it's the same exact half equation that we had in this question. Do we have to balance the electrons because of the 2? So which one would that be from? It wouldn't be ClOH minus because ClOH minus is not an ion. That would be 2 ions that you place together. We have to figure out which one of the ions is going to be discharged. It wouldn't be both of them. Is there a way to get the OH minus equation without learning it off? And you could try to balance it yourself, just like you would a regular balance reaction, but I definitely recommend learning off this one alone. And let me go back to this part. Remember, ClOH minus is not an ion. It's Cl minus or OH minus. And you have to figure out which one is going to be discharged. And for the question on the physics crash course, yes, it's the entire syllabus. And yes, the OH minus, it's easier to learn off that particular equation. You are just learning off one, and for the rest, you can come up with it. Now, this would be another mole calculation. And we didn't get a chance to do this on our session on Wednesday. So luckily it came back up in this question. Does electrolysis always come? In the past couple of years, it has come in every year, Jan and May, June. So if it continues that same pattern, then you could expect electrolysis to be tested in some way in your paper. But it's not definitive. They can change up what is tested. So you have to put the state symbols, and yes, your state symbols are super important for balancing any kind of equation. All right, so we need to calculate the volume produced, measured at room temperature and pressure, or RTP, during the electrolysis of dilute aqueous sodium chloride if a current of 1 amp was used for 30 minutes, we are getting Faraday's constant, we are getting the molar volume at RTP. So how many of you are familiar with this type of calculation? Electrolysis also has calculations involved. And we could break it down into 3 steps. So those of you who are doing physics, how do we calculate the charge? We are given current, we are given time. Could you all give me an equation? And Nicholas, I saw you have it worked out. All right, great. Q is equal to IT. Excellent. And I would recommend that you guys learn it off because notice your question does not state use Q is equal to IT. It is in your syllabus as well for chemistry. Make sure you know it. It looks like absolute garbage. Well, it's 5 out of 15 marks, so make sure you guys could attempt these type of questions. It's become very popular. All right, so after we use Q is equal to IT, the second step that we are going to do is to figure out the number of moles being produced. And this is not a usual mole calculation. We are not going to use any of the concentration equations or any of the basic mole calculations we did last session. We need to utilize Faraday's constant as well as your half equation. This is why it's important to make sure you balance your half equation. And I'm writing Faraday's constant, which is 96,500 coulombs. The third step is when we have our moles to go from moles to volume. And I'm bringing back a little flow chart that we used in our Wednesday session. If we have moles, it is possible to calculate volume. And we'll be using this equation here. Moles by volume at RTP. So this question could be solved in 3 steps. Does minutes need to be changed to seconds? That is correct. So can you guys go ahead and convert time into seconds for me? And I'm doing step 1 here. Let's calculate the charge. So Q is equal to IT. It's very important to write your formulae and to show your working. So our current is 1 ampere. That is in SI units. Nothing needs to be converted. Every minute has 60 seconds. So that would be 30 by 60. So 1800 coulombs. Excellent job, Isaiah. So next, we need to figure out how much charge was needed to produce that 1 mole of hydrogen. So step 2 is to calculate the number of moles. And I'm putting a star because we are not using any of the calculations we would for volumetric analysis or basic mole questions here. So this is from January 2024. And let's write down the half equation because yes, it would be easier. So our half equation was 2H plus to give H2 gas. And the reason why we're using this particular half equation and not the OH minus 1 is because you want the volume of hydrogen gas produced. So we are using this half equation. So first of all, can you guys tell me how many moles we need to produce 1 mole of hydrogen, moles of electrons? So we are looking at the coefficient in front of your electrons. And the coefficient in front of this is just 1. So it's 2 moles of electrons. Excellent. is needed to produce 1 mole of hydrogen gas. And this part, you always get this information from your half equation. What does the 2e minus stand for? It means that you need to add back 2 electrons to convert the ions and get back a neutral atom. And those atoms covalently bond to give us a molecule. So what we want to do now, we want to find the charge it needs in order to produce that 1 mole. So we are going to multiply the 2 by Faraday's constant. And Faraday's constant is just the charge it takes to produce 1 mole. You are given this value, so we are just going to substitute it here. 2 by 96,500. So when you guys multiply that, are you getting 193,000 coulombs? And this is needed to produce 1 mole of hydrogen. So the 2H plus is aqueous, correct. Any ion has an aqueous state symbol. So what we want to do, we just want to find out the number of moles in the 1800 that we calculated from before. So this part is just a little bit of maths. We want to figure out how many moles being produced here. So what I would tell you guys, if you are not very good in maths, is to find for a middle step. Just find for 1 coulomb first. We make a fraction that we aren't going to work out. And your numerator is just whatever is on the right-hand side. So that is going to be 1. Your denominator is whatever is on the left-hand side. And leave it as a fraction. You want your final answer to be as accurate as possible. So Isaiah says cross multiply. Yes. So if you're good in maths, you don't even need this middle step. It's just there in case you all need it. And for your final one, you are multiplying that exact fraction by 1800. So yes, you guys can cross multiply. For those of you that are good in maths, this method is just for anyone that's not as confident in cross multiplying. And what are you guys getting for the number of moles here? You all can give me the answer in decimal places or in standard notation. .009 moles, all right. So 9.3 by 10 to the minus 3 moles. Or if we are using decimal places, 0.0093 moles. We try to give our answers accurately as possible. So for moles, we could give 3 or 4 decimals. All right. So we have the number of moles now. The last step is just to calculate your volume. And now we could utilize the basic equation. Volume is just the number of moles by the volume of 1 mole at RTP. This is stated in your question as well. So it would be 24 dm cubed. Would they ever ask for standard form? No. In chemistry, you could just give the answer in standard form if it's a very, very small number. If not, you could stick with decimal places. So correct. Then we multiply by 24. So what is the volume that you guys are getting? And as for your question, after this, I don't know if we would be having any more. because tomorrow we have a physics crash course all day. So it might be difficult to get any lives going on tomorrow. And don't forget that your answer would be in dm cube. So 0.224 or 0.22 dm cube. If you're giving your answer in cm cube, it would be approximately 224 centimeter cube. But what I would recommend here, because the question gave you the molar volume in dm cube, you give them back the volume in dm cube. Any questions on this calculation? What I would recommend is that you guys show your steps. It is 5 marks. You are not going to get 5 marks for just showing your final answer alone. You have to show them how you break it down. You have to show them equations, statements where necessary in order to get your 5 marks. So in HSB Live, you guys would have to ask Mr. Springer when he comes back. All right. So let's see how much we could get done of another question. So in order to find, yes, we need to multiply the number of moles of electrons by Faraday's constant to figure out the charge needed to produce 1 mole. And you would always be using the half equation to help you get that coefficient. So would it be better to do past papers at this point instead of cramming your syllabus? As many questions as you guys could do, because you would notice that chemistry is not just memorizing and regurgitating. You have to be able to apply yourselves. So can you number your steps like how I did? Yes, you can. Or you could just simply make sure the marker can see the different steps that you're taking. It doesn't necessarily have to be exactly like mine. So it has another way to do this. So Jaden, this is a way that is usually taught if you guys have the concise. These are the steps that they require you to use. So it's the only one that I use. But if you have another way to do it, make sure you explain it properly in your statements. So what is the hardest topics in chemistry to learn first? I would say maybe moles. A lot of students have problems with moles. All right. So are you guys ready for another electrolysis question? Let's see how much we could get done. So I'm seeing that you guys are asking for questions on organic. So Mr. Springer said that he has an entire playlist of organic videos for you guys on his channel already. So you guys could take a look at it, all right? Topic predictions. For chem, it changes up all the time, but I could tell you guys what topics are common. As of late, electrolysis has been coming every year, so it's something to make sure you understand. Moles will always make an appearance in some way or form. And it's been a while since they have brought a volumetric analysis, so you guys could prep for that as a question 1, prep for rates as a question 1 as well. Also, it's important to know your trends in the periodic table. That's a very common question for question 2. And for organic, it's a bit difficult to predict what would come because, as you guys know, it's tested in 2 questions, question 3 and question 5. You would have an easier one on topics like the different series, as well as structural isomers, and then a more difficult question on reactions. Does qualitative analysis always come? No. Question 6 is usually on section C. And because you only have one main question for section C, they change it up all the time. You guys don't get a periodic table either. All right, guys, so we have at least 12 minutes remaining. Let's see how much of this May, June 2022 question we could get done any time that we have. And And this is showing us an electrolytic cell for aqueous copper sulfate using copper electrodes. So guys, this copper electrodes here, what does that tell us? Is it an active electrode or an inert electrode? So what about polymers? Polymers is also an important topic. It tends to come as a question 5. So the electrodes are active because copper is a metal. It will take part in the reaction. So this question is going to be fundamentally different from the one we just did. In the one we just did, it was an inert electrode. When you have active electrodes, it takes part in the electrolysis process. And you guys would see the difference between the two when we get to the part where we have to figure out what ion is being discharged. So again, could you guys figure out which one is your anode, which one is your cathode? So this is our positive electrode. Our positive electrode will attract negative ions or anions. So this has to be our anode. B is going to be our negative electrode. It will attract positive ions known as cations. So this is our cathode. So state whether the electrodes used are active or inert and give a reason for your answer. So it is an active electrode. And can you guys give me a reason why it might be active? Our electrolyte is copper sulfate. So you notice that the electrolyte itself has copper. Our electrode also has copper. It's made up of the same type of materials. So what does the negative and positive mean? The minus and the VE just means negative. It's just shorthand. And the positive VE means positive. So our justification is that it's made of the same material as the electrolyte. So that's why it will take part in the reaction. And yes, electrolysis questions tend to be similar in format, but not exactly. They tend to change up what they could ask you guys sometimes. Deduce what occurs at the cathode and what occurs at the anode in an electrolytic cell. So if we had to describe what occurs at the cathode, for example, we had the 2H plus 2 electrons to give H2. Can you guys figure out if oxidation or reduction is occurring here? And you could use this to help you figure it out, oil rig. And to figure out if it's oxidized or reduced, we are going from a positive oxidation state to a 0 oxidation state. All compounds have 0 as their oxidation state. So notice we had a decrease in oxidation number. This means that we possibly gained electrons. If you look at the little acronym, the G here stands for gain. So that means at the cathode, reduction occurs. So oxidation occurs at the anode, correct? Reduction occurs at the cathode. And I saw someone asking if titrations always comes, and no, your question 1 could be on different topics. And as of recently, they have been trying to change it up a lot. So titration is a popular option for question 1, but they are bringing electrolysis, energetics, rates also as a question 1. So we could state for part 2 that reduction occurs at the cathode and oxidation occurs at the anode. And hydrogen is just an example that I was giving you guys to help figure out the oxidation state, to come to the understanding that it is reduction itself. And for oxidation, notice that the L here means loses. If we happen to lose electrons, you would notice an increase in the oxidation state. So we'll just make a note in our answer that the cathode has reduction occurring and the anode will have oxidation. So state which electrode is the cathode, which one is the anode. So we figured out from before, just going back, that A is the anode and B is the cathode. Identify the ions that will migrate towards the anode and cathode. So our electrolyte was a dilute copper sulfate solution. So we had copper sulfate plus water. Can you guys give me the 4 ions that are present in our electrolyte? So you can break apart water. Water has 2 ions. Copper sulfate also has 2 ions. We have H plus, correct? So that would be going towards the cathode. We also have copper. And remember, copper is Cu2 plus. At the anode, we have OH minus from the water. And sulfate has, what as its charge? So I'm seeing 1 minus. The answer isn't 1 minus. It's 2 minus. Write the half equations to show the substances produced at the cathode and at the anode. So remember, at our cathode, there's only one factor to use, the position in the electrochemical series. And copper is actually lower than hydrogen. So we have H plus, Cu2 plus. So which one is going to be discharged in preference at our cathode? So in this case, H plus isn't lower. The copper is lower. So our copper is going to be discharged in preference. So let's see if you guys could come up with the half equation. What would be the state symbol I'm writing for this ion? It's dissolved in a solution. And no, this part doesn't have anything to do with concentration. Remember that your cathode is just one factor. It's the position in the electrochemical, and copper is lower down. It requires less energy. So it would be aqueous, excellent. And all we are trying to figure out is how many electrons we have to add or take away to get one atom. This is our first step. So what am I putting here? I just need to look at the charge on the ion. It's Cu2 plus. So exactly what is at the charge, you are writing it back in front. So plus 2 electrons, excellent. Question, is copper a metal or a non-metal? We want to figure out if copper could exist by itself or if it has to form a molecule. It is a metal, right? So do you think it will exist as a copper atom? Or are we going to write Cu with a subscript of 2? The active electrode, it does affect it, but it affects the anode, what is being discharged at the anode. So correct copper could exist by itself, so it's just going to be solid copper. And this solid copper is actually deposited on the cathode itself. So during the electrolysis process, the cathode tends to build up. And is this half equation balanced? So remember what I said, you don't look at the number of electrons when balancing it initially. You look at the number of atoms. I have one atom here and one ion here. So once the atoms and the ions are balanced, that is it. You don't look at the number of electrons at first. It's only if we happen to put a number here, then you change what is in front of the electrons. So this is already balanced, and we already have a positive charge in front of the electrons. So this is our balanced half equation at the cathode. Now at the anode, do you guys remember how many factors we have to consider? The cathode was just one factor, the position in the electrochemical series, but the anode is the more complicated one. We have multiple factors. We have 3 factors. Excellent. So what is the most important factor? And alright, the factors here, our most important factor is if we are dealing with an active electrode. So no, the electrochemical series is actually the least important factor for your anode. So it's factor number 3. And I'm just writing it shorthand, electrochemical series. The second factor, the second most important one, is whether you are dealing with a concentrated electrolyte. So just make sure you guys memorize these 3 for the factors that affect discharge at your anode. Now in this question, we have an active anode. So this is the factor that we are using. We aren't going to be using 2 or 3. And this is why electrolysis could be difficult for some students, because in the previous question we did, we had to use the electrochemical series. There are other variations where they give you a concentrated solution, and the third variation is when they bring active electrodes. In each different variation, what could be discharged at the anode is different. So how do we remember which factor is going to affect the electrodes? You just remember the 3 factors in those order and go back to look at the data on your question. Active just means it's going to take part in the reaction. So let's go back to the first part of the question itself. So we have electrolysis of aqueous copper sulfate using copper electrodes. So it's an active electrode here. So from the time you notice you have an active electrode, that factor is the most important thing we are going to use. So let's go back to the factors. If it's an active electrode, it means copper is going to take part in the reaction. And it means that the copper anode here is actually going to break down and become part of the electrolysis process. And this one is the hardest variation. So let's say this is our anode. The anode is made up of copper. During the electrolysis process, the copper breaks down to give Cu2 plus ions. Throughout the process itself, you would notice your anode shrinking. It gets smaller and smaller. So besides copper, what are other active electrodes? For your level, it's just going to be copper. That's the only thing you guys would see. So from the time you all see with copper electrodes, you know automatically it's active. If you see graphite or platinum, that is in it. So you can see other metals, yes, but just for CSEC, all you guys need to know would be copper. All right, and to figure out our equation at the anode, we are breaking down copper solid and it's producing the ions. So at the anode, it's the same exact thing at the cathode, except you're writing it in the opposite way. Because initially, our anode is solid, and because it's active, it's taking part in electrolysis and it's breaking down. It would give the Cu2 plus ions and electrons. And what's the electrochemical series? That's just the position of the anions in order of reactivity. So yes, the Cu2 plus ions that's being liberated goes back into the electrolyte itself. So all you would notice in this particular situation is that your cathode becomes bigger because copper is being deposited over time and your anode is being used up. So it becomes smaller and smaller. Why do you not use OH minus or SO42 minus? And it's simply because of factor number 1 here. This is the most important. Once you have an active electrode, none of the other ions matter. It doesn't matter if it's a concentrated solution. It doesn't matter that we have OH minus or SO42 minus. That active anode takes preference. It's the most important factor that we use. And also, because copper is going to require less energy to break down than it would be to discharge OH minus and SO42 minus. Again, electrolysis is a lazy process. It goes in the part that would require the least amount of energy. So in the case, if it was a graphite cathode, what would be the half equation? So no matter what your cathode is, the cathode only has one factor. That's the position in the electrochemical. So our equation of the cathode would be exactly the same. If it is a graphite anode, then we would use the last factor because we would have an inert electrode. We have a dilute solution, so factor number 2 does not apply. In that case, you use the electrochemical series for nonmetals. So if it was factor 3, then you use OH minus and SO42 minus. Correct. What would happen if it was factor 2? So Sharika, with a concentrated solution, it must have a halogen ion. So let's say it was NaCl and H2O. If it was concentrated sodium chloride, then the halogen would be discharged. All right, guys, so any more questions on the factors? This is a very unique situation, so make sure you guys learn what happens when an active electrode comes. So can you also write it as Cu solid minus 2 electrons to give Cu2 plus? It's not necessarily wrong, but you are trained from now to have a positive sign in front of your electrons. And if you go on to CAPE at Unit 1 and Unit 2, you will notice that is being done as well. So practice doing it. So can we do one with a concentrated? All right, so let's see if we have time. I'm not seeing Mr. Springer's yet. And we have 1 or 2 things to finish out in this one, and then we'll quickly
I'm
go.
right here, but if you have the energy to do a next one, that's okay.
All right, so I can make up one for them. You could just give me about 10 minutes.
All right.
Yeah.
Fading into the mist now.
Okay. So what if you forget these state symbols? Usually state symbols, they put a big importance on them. So they might be a mark. If you have everything correct for anode and cathode, there's a chance that they could only give you 1 out of the 2 marks. It's very important. So using your answer in B part 2, explain why a redox reaction took place during the electrolysis of copper sulfate. So do y'all think a redox reaction take place? And redox just means reduction and oxidation at the same time. So at the cathode, what happened? Is it reduction or oxidation? And remember, oil rig once again. So at the cathode, we are going from a +2 oxidation state to a 0 oxidation state. So is this reduction or oxidation? Oxidation would be loss of electrons. We would see an increase in the oxidation number. But here we are seeing a decrease. So it has to be reduction. So we could explain that at the cathode, we are seeing a decrease in the oxidation number, which means reduction has occurred. And correct, Jaden, reduction always occurs at the cathode. What about the anode? This is a atom by itself, so it will have 0 as the oxidation state. And we would have +2. So 0 to +2 is an increase in the oxidation number, which means we lost electrons. So do you all think this is oxidation? So your teacher said focus on questions 1, 3, and 5. So I think that you should do all of your questions because that way you are affecting your profiles badly. 3 and 5 would be organic. 1 is section E and only part of it. If you neglect section C, that is question 6, again, that's going to affect your profiles. And for those of you that said oxidation occurs at the anode, great job. So that is how we would explain C part 1. We would explain that at the cathode, reduction occurs. And you could even go on to mention the decrease in the oxidation numbers. And at the anode, we saw that oxidation occurs. And I'm just writing the answer shorthand here, but you go into detail, you utilize your space and explain. Does the aqueous solution for an active electrode always be copper sulfate? That is the situation that your syllabus mentioned for you guys. So yes, it's only this particular one to pay attention to for active. The remainder of them would just be concentrated and dilute. So if an active one comes, it's going to be the same format as this question. It's going to be the same half equations for your anode and your cathode. Suggest one change that is likely to be observed at the cathode. Now at the cathode, copper is being deposited. So do you guys think the cathode would remain the same size? It would get bigger or it would get smaller? The cathode would reduce in size. Remember, it's being deposited on the cathode. Initially, this is your cathode. And as electrolysis happens, you notice little red deposits over the electrode itself. So it builds up to get bigger. All right. And let's use a couple minutes to do one question with concentrated. So this one I'll have to make up. And let me give you guys the information. So the question is stating we have a concentrated sodium chloride solution with graphite electrodes. So can you guys tell me the ions that are present in this solution? If it's a NaCl solution, it means NaCl dissolved in water. So we have 4 ions in total. So there would be a competition on which ion is going to be discharged at the anode and the cathode. H plus, that is correct. So from the water, we get H plus. We also get OH minus. And from NaCl, we get Na1 plus, Cl 1 minus. Excellent. So let's start off at the cathode. Let's get the half equation for what is occurring at the cathode. How many factors do we need to consider here? And your cathode is the easier one, guys. It's just one factor. Good. And what is that factor? Electrochemical series. Excellent. So at your cathode, it doesn't matter if you're dealing with an inert electrode, if you're dealing with a concentrated solution, if it's active. All you care about at the cathode is the electrochemical series. And we are looking at our 2 ions, H plus and Na plus. In your electrochemical series, Na plus is almost to the top. Hydrogen is more to the base, followed by copper. So which ion do you think is going to be discharged in preference? So the purple is a bit hard to see. Okay, so I'm going to switch over to another color. So is this one better for you guys? So the H plus ion is discharged. And this is a question for a concentrated solution. But remember, it doesn't affect what is going to be discharged at your cathode. It's just one factor. And that one factor is the position in the electrochemical series. So basically, it's the one closer to the top instead of the bottom. No, it's the opposite. The one at the base is going to be discharged in preference. So sodium is not going to be discharged because it's so high up. And let's see if we can come up with the half equation quickly. This is an ion, so I'm putting aqueous. How many electrons do I need to add or take away to get a hydrogen atom? Is it 1 plus? Is it 2 plus? Is it negative? You look at the charge on the ion itself. Copper is lower than hydrogen, correct? But we don't have copper in our ions. It's only H plus and Na plus. So I just have the copper there to help you guys imagine the position and the series. So it's plus 1 electron initially. Hydrogen is a nonmetal. So what am I going to write? Am I leaving it as H or am I writing H2? So Jaden, it's not water that we are forming here. It's just H plus to give hydrogen gas. So we are forming H2 in the end. And now we need to balance it. We have 2 atoms being formed, but only 1 ion. So do I need to put a number here? And if so, what number would that be? An excellent job. So you guys have identified that it is H2 gas as your product. So it's not water here. The only time we will get water is when you're dealing with the OH minus ion. And we are putting a 2 here. Is this my complete balance reaction or do I need to adjust another number? So I'm saying 2H plus 1 electron to give H2. We are almost there. Because we change the number of ions, it would change the number in front of the electrons. So I'm multiplying this 1 by 2, and I would get 2. So notice that the equation on the cathode is the same exact thing that we got for the first question we did. And the first question was a dilute question with an inert electrode. It doesn't matter if it's concentrated, if you have an active electrode. At your cathode, it's only one factor, the position in the electrochemical series. At our anode now is where that information on concentration will come in. How many factors do we need to consider? Is it the same question? So no, for inert they could change up what they would bring, but it's the same method you would apply to it. So one factor always for the cathode, 3 factors for your anode. And I'm writing the order of importance of the factor, whether we have an active anode, whether it's a concentrated solution, and lastly, the electrochemical series. So which factor are we using in this question? You all could comment 1, 2, or 3. And I'm highlighting that the question states concentrated. So Josh says 2. 1 is not going to apply here because nowhere did they say we have an active electrode. They said graphite, and graphite is inert. So you cross out that first factor. Our question stated concentrated. So automatically, this is the factor we are using. You cross out the last one. You only apply one factor for a particular situation. And what does concentrated tell us? With concentrated, it means that a halogen ion is going to be discharged. So Cl minus, Br minus, or I minus. So isn't this the extraction of chlorine? So technically, yes, but it can come in electrolysis where you have to figure out what is going to be discharged at your cathode and the anode. So Josh says that the Cl minus will be discharged. Excellent. So Cl minus, how many electrons do I need to add or take away here to get chlorine? And I'm just removing the factors for some space. I'm putting an aqueous in front of the ion. Initially, to form one atom of chlorine, I'm looking at the charge on the ion. So I'm putting -1 here. Yes, and for concentrated, a halogen ion is discharged. Nothing else besides a halogen ion. And Fl minus is not on the syllabus. The reason is fluorine is the most reactive nonmetal. Even theoretically, they wouldn't ask you guys about it. But if they do happen to bring fluorine, and fluorine is just F minus, it's the same procedure you would use. And excellent. So someone already balanced this half equation. Chlorine is a nonmetal, so we have Cl2. And this is going to be a gas. We have 2 atoms being produced, but only 1 ion. So we need to balance it. We put a 2 in front of the ion, and that means we have to change this number, multiply it by 2. So you could talk about the color with the cathode. It's only if they ask you for an observation. And for this particular question, you wouldn't see a color, but you would see bubbles because it's hydrogen gas. If it's diluted in this question, OH minus would be discharged at your anode. All nonmetals would be in a diatomic state, and most of the time they are gases, correct? Now, is this reaction completed, or do I have to do one other step? The hint is I need a positive sign in front of my electrons. So how can I make this positive? Just like a maths equation, I carry it across on the other side. So my final half equation will be 2Cl minus to give Cl2 plus 2 electrons. And that would be our half equation. So guys, any last questions on electrolysis? We did all of the 3 variations today. The first question was the dilute situation. Notice that our anode OH minus would have been discharged because we had to use factor 3. In the second question, it would have been an active anode. And in this question, it's concentrated.
It's like we are in close-up time, D.
Yeah. All right. So just one last question. Is it important to know the observations? So just be aware of if a gas is being produced, you would see bubbles. If something is being deposited, the cathode would increase in size. If the cathode is breaking down, it will decrease in size. And that's the main things to look out for. All right, guys. So you all could use this video to go over electrolysis. And these are the 3 big variations that they could bring. So I hope you guys have found this session useful, and good luck with your revision. So good.
Yes, thanks again.
Welcome.
Hello. Zio was fighting me down there, so I had to bring him with me. So Zio, I hope Zio wish you all the best in exams. Thanks for popping in. We have a hard session tomorrow in physics, a full 12-hour session. I will be teaching basically half, and Miss will be teaching half. If you all want to join in on that, this is the number here. I know you all have seen Miss Achilles' name, but that's the number there. So you can press that number and jump on in, right? So love and blessings, everybody. Thanks, Shazara.
You're welcome. Bye, guys. Enjoy the rest of your night.